we get into the topic, I just want to introduce myself really quickly. So my name is Pauline. I'm a freelance software engineer and consultant based in Amsterdam. And I've been doing that, sorry, I forgot to. I've been doing that freelance for about a year and a half. And before that, I was a software engineer at several product companies, also in Amsterdam. I'm usually talking about Git, so if you've ever seen me at a conference, that's probably what you've seen me talk about. I also give workshops and trainings in Git, so I really love talking about Git. If you want to hang out and talk about Git, I'm down. I'm an Amsterdam PHP organizer, so that's the Amsterdam PHP user group. And we have a meetup every month. It was yesterday, actually. Of course, I couldn't be there. I'm also a mom. I have a 2-year-old. She's very cute. And my hobbies are American football, if you believe it. So if you see bruises on my arms, I'm okay. I just play football. I like knitting, and more recently, I've been dabbling in electronics and tinkering with that. I'm not very good at it yet, but one day, soon. And that's my handle on Twitter. Feel free to follow me. Be warned, about 20 to 30% of it is tech, and that's being generous, but if you're into a little bit of tech and a lot of nonsense and opinions, then feel free to follow. Okay, so enough about me. Let's talk about more real-time communication, because of course we just had a really nice talk by Brian. So this is going to be a very different scope. So I'm going to talk about real-time communication in WebSockets in PHP, believe it or not. And some people who may have dabbled in WebSockets before may think that, why PHP? Well, I have it on good authority that these days, with all its performance enhancements, modern PHP is actually fairly okay for this sort of stuff. I mean, it's not going to be as performant as Go, for instance. But it's definitely possible, and it can handle many connections simultaneously and be fairly efficient. I do want to set some expectations about what this talk is and what this isn't, which I think is especially fair after having just had an excellent talk about Mercure. It's going to have a very different scope. And what you can expect this talk to be is it will be a bit of fun. It's not going to be too serious. It's not going to be anything production ready necessarily. We're not going to go into like scalability or being very performant or anything like that. We're also not going to go into, deep into securing your WebSockets. We can definitely talk about that, but after that, maybe if there's questions or off stage or something like that. But mostly this talk is just going to be tinkering with, like if you've not looked into real-time communication yet and you're kind of looking into different options and want to play around with like your own little WebSocket server, then hopefully I'll be able to kind of show you the basics of how to get started with that. Okay, it's not going to be about Mercure, but maybe a little bit. Maybe we'll touch upon it a little bit at the end. Of course, you've already had a fair share of Mercure if you were in this track in the last hour. So it's really not going to be about Mercure, but maybe we'll hint at it a little bit. Okay, so how are we going to do that? We're going to build a Raffler. And not just any Raffler, we're going to build the kind of a basic version of the Amsterdam PHP Raffler because we raffle prizes at our meetup. And at some point, so that Raffler, the one that we had, was built on the Meetup API. I think at some point there was something that Meetup decided where the API wasn't free anymore, or they were being difficult, and the person who built the Raffler was like, I'm going to kill the Raffler. So we're going to need a new one. So I was like, why not try something in WebSockets? So I built this Raffler in WebSockets, and we're going to just make kind of a basic version of that in the time that we have. So the functionality of the Raffler is I want to have a host that can start a Raffler. So the host being like the meetup host with like the presenter. So the host starts a raffle, players can join the raffle, and then a winner is picked at random, and everyone is notified of who the winner is. And that can happen a few times. So like we can pick several winners because we'll have several prizes. Now the requirements for this project is going to be that players join a raffle using a join code so that we know that they're actually at the right raffle game at the right time and in the right place. A player list is shown on the presenter screen, so on the host screen. Every player is notified on their own device, which is probably going to be a phone. And we want that all to be in real time. So we have a few options. So one possible approach is to just refresh the screen constantly. So the host would refresh the screen and an updated version of the player list would appear because the screen is refreshed. And similarly, the player would have their screen refresh, and if they're a winner, then they'll see that, and we could do that automatically if we want. Of course, that's not very real time. It's definitely not very efficient traffic-wise, and it will also impact the user experience because obviously having your screen refresh while you're doing something is not ideal. So then there's polling, which I think is fairly popular in PHP land, being historically a bit more of a procedural type of situation. So in this case, the player would be constantly hitting an endpoint asking if there is a winner and who that winner is every few seconds or so, and then the host would be asking the server if there's any new players, compare it to the list that they already have, and if it's different, then they would update the list on the screen. Again, not very real time. Of course, it depends on how often you want to hit these endpoints. Maybe you're doing it every half a second, makes it a little bit more real time. But not super real time, so like every player is gonna maybe know that they've won before someone else already knows they didn't win. And again, it's not very efficient to constantly be hitting these endpoints. It's another strategy that Brian was talking about before, that I think you were saying it was something like 60% of your traffic or something was polling. Yeah, so not very efficient. So enter real-time communication. So there's some different protocols, some different options. Some options would be, so these are examples. WebRTC is one option. It's an open source real-time communication protocol by Google, which is kind of the standard for streaming through your browser. So it's supported by most, if not all, modern browsers. And I'm guessing things like Google Meet and Jitsi possibly. I never remember if it's Jitsi or Jitsi. I think it's Jitsi. But like video conferencing and stuff through the browser. That's what it's pretty popular for. And then, of course, there's Mercure, which we just saw talk about. If you were here, in any case, who was all here before for that talk? Okay. So a fair few people were also in the French track, and about half were here. So I'll just kind of reiterate a little bit, like a very, very TLDR of the concept that Brian was just explaining. So Mercure is something that works with Symfony. There's a nice bundle for it, and it comes integrated in an API platform. It can be used separately as well. You don't have to use Symfony or API platform. It's kind of designed to be a layer on top of your API, so it's very HTTP focused. It's going to feel very familiar for you if you're used to HTTP. And it leverages modern HTTP features to improve like efficiency and persisting your connection and that sort of stuff. And then there's Livewire. I don't know if there's any Laravel people. Well, there's Livewire. I think Symfony UX, from what Brian was describing before, is very similar. So it's like a component-based server-side rendering, and it does it with AJAX calls, and then the server renders some HTML, and then it's, according to the documentation, intelligently updates the DOM, but I don't know what that means. But it sounds like it's kind of the same as Symfony UX, but AJAX based. Okay, and then there's WebSockets. And WebSockets is kind of sets itself apart from a lot of other options in that, yes, it is real time, but it's also full duplex. By full duplex, I mean It's a type of communication that, as opposed to simplex, which is one-way communication, so one party kind of broadcasting almost to another. Well, broadcasting also suggests that there's many different connections. It's just one-way communication. And then there's half duplex, which is two ways, but one party can only say something to the other party when this other party has stopped talking. So imagine like a walkie-talkie type situation. And then full duplex is a communication channel is opened and you can send or receive messages simultaneously the whole time. So like asynchronously, back and forth. I throw in a message and the other end receives it, and at the same time, this other end throws in a message and I receive it. So that means that communicating between client and server becomes a bit more of a fluid kind of conversation. So in this case, you'd have the host, so the meetup host, would ask the raffle server, hey, I want to start a raffle. Then the raffler responds with, okay, the code is 2738. And then the raffler tells the host, hey, Alice joined, and so did Bob. Host asks, okay, so who's the winner? And then the raffle server says, Bob. And similarly, every player would have their own little conversation with the server. So they open up a connection with the server, and they have this little talk with the server. Okay, one very important thing to keep in mind about WebSockets is that it's very bare bones. It really just opens up a tunnel, and that is it. What you do with that tunnel is completely up to you. The entire protocol leaves everything else up to you, basically. So it does not offer any authentication. It doesn't tell you how to handle your authentication. It has no message protocol, so it doesn't tell you any type of standard for message structure, what kind of format. You know, it could be just a simple string message. It could be a binary data. It doesn't offer caching, handle sessions, persistent connections. It doesn't handle packet loss or like state consolidation, like with the missed events kind of mechanism that Mercure has, right? So all of that stuff is something that you will have to handle in some way or another. And you can use third-party libraries for that. There are packages and libraries that will solve some of these issues for you. Or you can just write your own solution, basically. All right, so this is our project's, the concept of our project a little bit, like a vague structure. We're gonna have our Raffler is going to be a little WebSocket server in PHP, and then we'll have two JavaScript WebSocket clients that will be chatting to the WebSocket server, and that's going to be the Raffle host and the player, and we're going to be sending messages in just JSON strings. Okay, so this is going to be our project structure. We're going to have a little start command that will start up the WebSocket server. So we're mostly going to look at the code of the WebSocket server itself, less so of the client. So this is the server. And then we're going to have our SRC directory with all our application code. And I say application code because it's you can barely really call it an application. It's very, very small and basic, but it's about the WebSockets, not so much about the PHP. Then we have a vendor folder and some composer files because we are going to have exactly one dependency. We're going to do a very bare bones, and the one dependency is going to be Ratchet. And Ratchet is a library in PHP for communicating with WebSockets. So it offers a client if you want to connect to a WebSocket server as a PHP client. You can do that, and then just listen to whatever comes back from that WebSocket server and send it messages. But it also offers a WebSocket server, which is really simple to kind of set up. So let's have a look at that. Is that readable? I hope so. Okay, great. So we're going to start with having our little Raffle server class that's going to implement Ratchet's message component interface. So this is really going to be like kind of the messaging layer. You can see that we have an SPL object storage of clients. So clients are going to be all the connections that are open. This is our temporary Raffle server class, by the way, but this is just kind of demonstrate how you can get started fairly easily. Then you'll see that this message component interface offers a few event listening type methods. You'll see 4 here. On open, which is to say on a connection opening. So when a client opens a connection with your WebSocket server, we're just going to attach the connection to our list of connections, which is our connection pool. And then on message, which means on an incoming message, we're going to, for now, just echo the message and send back Pong to the connection. Then on close, we have to remove our connection from the connection pool, because you can use this connection pool to send messages to all your connections. Of course, if connection is closed, we don't want that connection still in the pool and try to broadcast messages to it. And then on close, which means to close a connection, already did that, sorry. On error, we're going to just close the connection for now. Then underneath that, in the same file, this is where we start up our WebSocket server. So it's going to listen on port 8080, and then in our root path, we're going to instantiate our Raffle server. Don't worry too much about the array option. It's allowed origins. It's just copy-pasted from the Ratchet documentation. So I'm guessing the asterisk means all origins allowed. And then we're going to echo that we've started the Raffle server, and we're going to run the Raffle server. Okay. I think we can already demo that part. 1 second. I'll try to put the microphone down gently so you won't get a beh. All right, so we have our Raffle server running. Then instead of having to write your client in like a little JavaScript file or in the console, you can use one of many WebSocket client test clients that are browser-based. I really like this specific one. I can zoom it in a little bit if you want. I really like this specific one. It's called WebSocket King because it allows you to save your payloads. And it allows you to open several connections at once, which is quite nice because you can see in real time how they're kind of interacting with each other. So that's pretty nice. So we're just going to open up a new connection with our WebSocket server. And for now, we'll just send it ping. And it will send back Pong. And here we see that the message has been received. So pretty straightforward so far. Clicker. Okay. Now to look at a bit more of our application-specific code, we'll have a participant that is just a wrapper around the Ratchet connection interface, and we'll be able to send it a message. Then the message is our own value object. It's just going to have a plain string value. And we'll need something to handle incoming messages. So for now, we'll just do the exact same that we were doing, plus echoing the actual message value. We'll just echo message received. And then in our Raffle server class that we had, we'll have to make sure that we inject the message handler. And you'll see that in the onMessage method, we're now using the message handler to handle the incoming message. So let's see if that's still working in pretty much the exact same way. So we'll start our server again. And then we can go back to here. We have to reconnect because it was down before, so that won't work. Now we'll send hey-o API platform. And it'll send back Pong again, and this time we have our message echoed there. Okay, so it still works as expected. Now Now we want to start making our raffle pool, which is going to be a little class that actually handles the kind of raffle mechanics itself. So you'll see there's a little array of participants. That's going to be our players, because we want our connection pool to not automatically be in a raffle. They need to send a join code first. And then we'll have a host who's the only one who can pick a winner. And we'll have a join code, which is nullable. And if it's null, we'll know that there's no raffle in progress. And if there is, then we know that there is one in progress and we need to check it. So then we'll have a few methods. We'll have start, as in start a raffle, and then add player and pick winner. Let's flesh those out a little bit. So the start method, we're just gonna, and again, like, of course, you'll see this nice hard-coded plain text password. Of course, in real life, that's not what you want, but for demonstration purposes, it's all simplified a little bit. So we're gonna check the host pass. If that's 102, we're gonna continue. And if not, we're gonna throw an exception, which at this point, you'll probably want to catch. You'll want to handle these exceptions, because remember in our raffle server class, we were saying that on error, we're just gonna close the connection. We probably don't want to do that. We want to probably catch those exceptions and send a nice message to the user saying, hey, you did something wrong, correct it. And then we're gonna set the join code in the actual raffler that's randomized, but now we'll just do ABCD. We're gonna assign the host, and we're going to send the host back a message with the join code. Then to add a player, it will take a player and the join code. It will we will create a hash out of the username that the user sent, because we'll use that as an array key to just be able to look the player up quickly and also check that the username isn't already taken. And we have to hash it because usernames can be anything, because that's another thing that you need to remember with WebSockets, is that anything is user input. So you kind of want to make sure that you treat everything as user input, because they could literally be sending you anything. And if we're going to assign a username to an array key, then PHP is not going to be happy with just anything being an array key, probably. Then we're going to check if there is a join code and if it's valid, and if not, we're just going to say no, it's not a valid join code. There's no raffle in progress with that join code. And if the username already exists, we're going to tell them the username is not available. Then we're going to send a message to the host that a new player is joined, because then the host will receive an event basically that says new player joined, and they can append their player to the players list on the host screen. And then we'll assign the player to the array of players. Okay, then the pick winner, we're going to do a very loose comparison between the host object and the person who sent the message. Again, not ideal in real life, but for now. And we're going to check that they're the host, and if not, we're going to throw an exception. If the count of players is less than 2, there's not really a winner to pick, so we're not going to let them do that. And then this is another great feat of PHP. We're going to make a copy of the players array and just shuffle that, because shuffle takes an array by reference, which would screw up the original array that we still want to use. And we'll just take the first player on that shuffled array, and that's going to be our winner. So we'll send the host a message saying who the winner is, and we're going to notify all the players. And this is where it's nice to be able to have just this connection pool, because it's really straightforward to just loop over all of your connections and send them all a message at the same time. So we're going to say if this if the player that we're looping over is the winner, we're going to send them a message saying you're the winner, and if not, we're going to say better luck next time. Okay, so now we have our nice raffle pool with our nice, very subjective, but now we have a raffle pool with some methods, and we need to be able to actually call those methods, right? So we're going to do that by transforming incoming messages to actions. So our message structure is just going to be JSON again. And again, this is not any type of standard or protocol. It's just something I made up, because you have to make something up yourself, basically. So our incoming messages at least, are going to have a message type, which are going to be written like kind of a command format almost, register player, pick winner, that sort of stuff. And then some extra data, and the message handler will expect certain data based on the message type that we're sending. Speaking of the message handler, it's only doing this for now. So we want to actually start parsing these different message types. So let's flesh out our message handler. So it's going to parse an incoming message. It's also going to take the from connection. So we're just going to decode the message value and vaguely check that there is a message type in there. And then based on the message type, of course, you can also make a little factory and stuff for this. But in this case, we're just going to do a quick switch. We're going to, if it's a start raffle message type, we're going to check if the password is set, and if so, we're going to try to start a raffle. Same goes for a register player. It's going to check if the data that's expected is there, and if so, we're going to add a player. And pick winner, same deal. There is no extra data in the pick winner, just the host check, basically, and the default is unsupported message, because again, you want to kind of handle anything that's unexpected. Before we go there, we'll just look at what that looks like now. It's a bit more interesting than the last two demo times. So we'll go back to here. And this is where it kind of comes in handy to have these saved payloads. So we'll have the host connection here, and we're just going to copy this one in connection 1 into connection 1. So this is our start raffle. And we're getting back a code instantly. And then we're going to have 2 players join the raffle. So we'll say Minsk here, that's his username. First we need to connect, sorry. That's the only thing that it doesn't pre-fill the connection already. So we're going to send that. And then for the other player, we're also going to connect and send the same message. But we're going to say boo. That's their username. So now we've got 2 players, and you'll see that the host has received 2 messages saying there's players, and then we'll just say I want to pick a winner. And then you can just keep sending that message and keep getting a different person out, which will be vaguely 50-50. Okay, so that's all great. But what about the other side? So what does the client side kind of implementation look like? And I've prepared a very kind of basic version of the UI just to show you quickly what that would look like. So this is a very basic version of the UI. And for now, we'll just enter the password. And for now, it's just, no, I don't want to save that. It's just logging the message, or the password. It's not sending a message, I mean. Then here we have the actual code. It's React, and I promise you don't have to know how React works. I'll just walk you through it real quick. So if there's no join code, we're going to show the host key input. So that's what you're seeing now. And if there is a join code, we're going to show the little message for players saying you can join through this code. And you'll see that on the password submit, it will call this method. And here, as expected, it just says it's console logging it. So what you would want to do is, I'm going to try this with one hand, is instantiate a WebSocket API client thing that's a standard JavaScript one. You do have libraries for this as well that will have some nice extras. But it is a part of standard JavaScript. So here we have our connection, so that would connect. And then here you would say, instead of logging it, we're going to send, and we have to JSON stringify our little message that I'll just copy from here. There. So we'll just send this message, and instead of hard coding it here, we'll just say password, because that's what the value of the password in the field will be assigned to. And then to listen to a message that comes back, we will, because it's a message handler, or an event listener, sorry. So on message, we're just going to, for now, take the message and console log the message, just to see what it would look like. And it should be hot reloading. So instead of console logging the input, we get the message that's sent back. So the WebSocket, JavaScript WebSocket API will wrap the actual message in its own object with a bunch of extra stuff, but the actual message will be in here in the data key, or property rather. So that's what we want to do something with, and then we would just, instead of logging it, we would go and parse that data thing. Parse. So instead of JSON stringify, we're gonna do this. Message data, and then we're gonna go set join code to data code. Now, of course, this isn't super robust if you're expecting different messages. So you would want to kind of handle it in the same way that we're doing on the WebSocket server side, because the code may not even be there if you're expecting other types of messages. But let's just see if that works, and then you'll get the message back and it will be assigned. So that, ooh, spoiler alert. Where is Canva? Oh, I think I probably closed the Canva tab. 1 second. Oh, no, I didn't. It was just gone. This is where we were at. Okay. So that's kind of the basic client-side implementation. Some possible improvements and missing features that are, some of them are already on the real-life version and some aren't, is some proper authentication, which, yeah, the protocol leaves completely up to you. There are some widely used strategies. Unfortunately, authentication is not like on the protocol level defined, so you kind of usually do it on the first message. So that's a really common technique. Then we want to remove a player when the connection drops, which can definitely happen. So we don't want to show them in the player list anymore. Some sort of reconnection mechanism would be nice, because if networks are flaky, then someone might drop off for maybe 1 or 2 seconds, but we want them to not be able to kind of feel that too much, right? Some improved error handling, sending some nice human messages back to the client. Optionally, a keep alive mechanism. I had to find this out the hard way, but a lot of hosts, looking at Heroku specifically, in my experience, they offer the option for running a WebSocket server, but they will have a timeout of like 30 seconds on the client connections. So basically, in the real Raffler, we've had to build kind of a ping mechanism that every 20 seconds you have to ping the server, otherwise it just drops you. So that was fun the first time I deployed it. I was like, what's going on? This isn't doing it locally. And then I had to read some very niche part of the Heroku documentation to find out that this timeout thing was an actual feature. You would probably want a maximum amount of players. I don't think a meetup raffle needs 1 million players. Neither will it probably take 2 days to complete a meetup raffle. So we'll probably want to have like a max time for the raffle. And I'm sure you can think of about 100 other things. And of course, some of these are kind of, well, game mechanics is a general term, or a generous term, but kind of more relevant to the game itself. Some of these are the messaging kind of protocol. And again, you have to kind of sort that out yourself. Either write something else, write something yourself, or use something else like a third-party library to solve some of these problems. If you don't feel like doing that, of course, there's something like Mercure, which is also a viable option. You could even quite easily have the same Raffler and just change it into a Mercure application instead. In that case, you would, instead of having the Raffler be a WebSocket server, it would just be an application that authenticates as a publisher to a Mercure hub, which is just, you can spin up a Docker container or run the, because it's a Caddy based server, and you can just run that server. It's basically just a web server. And then the publisher, the host would publish events. And it will feel much more familiar to you probably if you're used to APIs, because the authentication mechanisms are just according to what you're used to from HCP, for instance. And you just be posting. So posting and getting is what Mercure is based on, so also very familiar. And the host and the players would just subscribe to a raffle topic, basically, and then they would get events in much the same way as we just saw client side. We just wouldn't instantiate a WebSocket object. We'd have like a event source or something that would wait for messages. So that's definitely an option as well. If you're basically in this use case, this would be perfectly appropriate. If you're maybe doing a really small application where you're just doing a quick chat box or like a little peer-to-peer gaming situation, you might think, oh, I'll just set up a WebSocket server. Just don't forget you have to actually secure it and that sort of stuff. Now, before we go, hopefully we'll have 2 minutes left to actually show the end result. And as is true to Amsterdam PHP, okay, it's a free dyno on Heroku, so it actually takes like 30 seconds to spin up, which I had spun it up before, but I guess it's idle again. Then I don't think we'll have time to demo it, because it's still spinning up. So in that case, I'm just going to thank you very much. Questions? Okay.
We've got 3 minutes, so
Let's see
maybe
if
the
there's
demo
questions.
is up.
Ooh.
Ooh.
After this question, we'll do a quick demo.
Thanks for this nice talk. I had a question about testing. How is it possible to test the different endpoints that we're gonna, like the virtual endpoints we create with our message handler in PHP? Is there a way to test that with whatever library? I guess not PHP init probably, but maybe is there another solution to test the behavior?
Yeah, that's a good question. I think testing asynchronous things, especially in a kind of an integration or like an end-to-end testy way, is also always very difficult. I don't know. I do know that like libraries like React PHP offer like an async testing bundle. I think that's more promise-based though, so I don't know if that applies here. So yeah, it's very hard to test. That's correct.
Maybe you want to show.
Oh yeah. Let's try this. By the way, if anyone does have a cool asynchronous testing library, please do share. So I'm just gonna start the raffle, and then in true Amsterdam PHP fashion, it's completely possible that something will break. So no, again, I don't want to save it. So try and join through either the QR code, if that's large enough. It will pre-fill the code for you, so you won't have to go to the URL. And then definitely don't put your phone on sleep mode, because depending on your OS, it will it will drop your connection and you will be removed from the player list. I hope you all like your avatars. Not me. That's a nice username. All right. I don't know how many people are still wanting to join, but it's already quite a lot of people. I feel like there's a bunch of people from. Oh yeah, we probably need the QR code still from home, online. Okay, so let's pick a winner. I'm sorry for anyone who wanted to join. Luckily, there's no real prizes except for eternal glory, so...
Cheat code. It's a cheat code.
Congratulations. And the sound is glitching, so true to tradition. Thank you.
Thank you, Pauline.